Hello everyone. In this class, I am going to explain that the conduction in the semiconductor. It will be in the two process. One is a diffusion process, another one drift process. Diffusion process it means the semiconductor current, that is electrons, can flow without application of electric field. For example, we can give a material without a conduction material. We will giving the current by the external producing by external voltages, giving the sum of a potential to the two different rods. That is copper will be connected, copper wire connected with the a load with the two different potentials. So it will be conduction. What will happen in the conduction field? The charge carriers of copper, that is electrons and holes, how can it moves in the application of electric fields. So you can see that the charge carriers ultra diffusion from different regions, that is higher concentration level to the lower concentration, until the charge carriers are equally distributed in the material. So this is a diagram tells about that moving of electron from the higher concentration gradient to the lower concentration gradient, as known as the diffusion process. So you can see that one of part is the which is the electrons are holes, which means electrons that is move on one side of a material will be the low electrons, means so electrons can move from one part to the another part. So it will be diffusion process. It will be moving from one to the another area. So this motion of the charge carrier produces the current component in the circuits, in the circuits. So different process is different from that. The diffusion. So from the potential we are connected with the electron band, the electron moves from the circuit and to the conduction band of semiconductor. Holes of semiconductor holes and moves in the valence band of semiconductor in the circuit. So similarly, it will be diffusion, means they automatically will be simultaneously gone from the two type of the answer gradient to the temperature gradient and the concentration gradient to the lower to higher. So higher to lower. Whereas the diffusion process is different from the moving of electrons in the conduction band, valence band in the circuits. So these are the different the definition for that the conduction of electrons. Under thermal equilibrium condition, the electrons and the holes are uniformly distributed in the crystal, and when no external field is applied to the conduction flow in the crystal. So where the crystal is the pure, we can use that crystal material for the finding that drift and drift current and drift velocities of electrons. So it will be used because the crystals are the pure material with no impurity atoms. We have to find the specific property of physical properties crystal material have been used for here. So drift current, when the electron will E applied to the semiconductor, charge carriers, that electrons and holes tend to move to produce drift current. The electrons drifting in the conduction band produce the current component J given by the given formula. So mu is the potential of mobility of electrons. So that is the mobility of electrons. The finding these are the mathematical component. So the different diffusion are present in the material. So it will be based on the electrons and holes respectively. The density different holes are given by that two different formulas. So it has the different areas will be used for finding the drift processes. So next class we have to go see the in depth of Hall effect, the application of drift current and drift process. The Hall effect is one of the main important method to find out the where the material has a p-type or n-type semiconductor. By the Hall effect, we can experimentally finding that p-type and semiconductor for the application of various application process. In this step, I have to stop here. Next class we have to depthly we can see the in depth of Hall effect by next classes. Thank you.